Okay, we'll move on to the next set of problems. This is 23, 26, and 31. List the potential rational zeros of each polynomial function. Do not attempt to find the zeros. So to do these problems, we're going to be using the rational zeros theorem, which is on page 243 of your book. And it says that the rational zeros theorem provides information about the rational zeros of a polynomial with integer coefficients. So the first thing you need to check for is that your polynomial has integer coefficients. So this one does. It has a 3, a -3, a 1, a -1, and a 1. And if the polynomial has integer coefficients, then the rational zeros theorem can be used to determine what the rational zeros are. To do it, or to use the theorem, you have to take the last term of the polynomial, or the constant term, which is a of 0, it's listed down here, and you use that term, and then you also use the first coefficient, which is the a of n term in the rational zeros theorem. So you take the 1 and the 3. So taking the 1, you determine what the factors of that are going to be, and that can be either plus or minus 1. And then you take the 3 and you determine what the possible factors of that are, and that can either be plus or minus 1 or plus or minus 3. And then you determine P over Q, which are the answer of which is going to give you all of the rational zeros, potential rational zeros of the polynomial. So you consider all the combinations of P over Q you can get. You can either have 1 over 1, which is just 1 plus or minus, or you can have 1 over 3, which would be 1/3 plus or minus. So those are your potential rational zeros for the polynomial function. It doesn't guarantee that they're going to be rational zeros of the function, but they're potential ones. So it provides some information about the potential rational zeros of the function, and we'll understand a little bit more about what that means when we graph some of the problems in the latter part of this problem set. So anyway, the answer to this one is P over Q plus or minus 1 or plus or minus 1/3. Okay, now moving on to 26. Here our last term, or our constant term, is 1, so that's a of 0. And our first coefficient term is 2, so that's going to be our a of n. And just like we did before, we determine all the possible factors of the 1 term, and that can be plus or minus 1. And then we determine all the possible factors of the first coefficient term, 2, and that can either be plus or minus 1 or plus or minus 2. And then we figure out what all the possible combinations of P over Q we can get out of this. You can either have 1 over 1, which is just 1, plus or minus, or you can have 1 over 2, which is 1/2, plus or minus. So in this case, the answer is P over Q, which is plus or minus 1 or plus or minus 1/2 as potential rational zeros of the polynomial function. Okay, finally, we have 31. And here our last term is 4, so that's our a of 0 term. And our first term is the 2 coefficient, so that's the a of n term. The factors of 4 are going to be plus or minus 1, plus or minus 2, or plus or minus 4. And the factors of 2 are going to be plus or minus 1, or plus or minus 2. And then for P over Q, or our answer, we want to figure out all the possible combinations we can get. So we can either have 1 over 1, which is going to be plus or minus 1. That's right here. Or we can have 2 over 1, which is going to be plus or minus 2. Or we can have 4 over 1, which is going to be plus or minus 4. Or we can have 1/2, which is 1 over 2, plus or minus. We can also have 2 over 2, which is just 1. We've already accounted for that, plus or minus. Or we can have 4 over 2, which is 2. We've already accounted for that as well, plus or minus. So the possible combinations you're going to get are shown here. And so for P over Q, or the possible rational zeros, potential rational zeros of the polynomial function, the answer is plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 1/2.